Welcome everybody to this exciting interview with the ARC Prize 2025 Paper Award first place winner, $50,000 prize for a paper called Less is More, Recursive Reasoning with Tiny Networks. Yes, this is indeed the TRM paper that took the world by storm. Can you please introduce yourself?
Yes, I'm Alexia, Jolicoeur-Martineau. I'm a research scientist at the Samsung SAIT AI lab in Montreal.
Amazing. Are you originally from Montreal?
Yes, I was born there.
Very cool. I'm really curious about the Samsung lab. Before we dive into, TRM and the paper, what's the name of the lab that you work at and what do you all get up to there?
Well, name is changing, but right now it's Samsung SAIT. It was SAIT AI lab. I think the name is changing a bit, but where we call it SAIL for Samsung AI lab. And it's a lab focused on a mixture of fundamental research and some more applied work for the semiconductor industry. And the idea is we're positioned to work with the Mila ecosystem, which we're like in the same building as Mila. So we can collaborate with the professor and the students, which make it easy to interact. And we get some freedom to do our own research on more fundamental stuff. But obviously, as in the recent year, as most labs have seen, it's been harder to justify fundamental research. Everything has been going toward more applied and applied. But this TRM work reasserted that, fundamental research can have strong value, which is great.
I think you did indeed do this. By the way, Mila is the Quebec Artificial Intelligence Institute.
Yeah.
Okay.
Yeah, with just more than Joe.
Okay. Very cool. Where did you go to school yourself, by the way? Just curious.
I went to McGill and University of Montreal and UQAM.
This is exciting, and I know I've heard a little bit about the reactions like within Samsung, but I guess just apart from your work related to ARC AGI and even TRM, what other projects do you get to work on at the lab?
So I've been always working on generative models of all kinds. So I went from images. I started with actually cat picture. I made the first generator of cat picture at the time. And I went to videos and tabular data, weights of neural network, video games, molecule. So I've dabbled with a bit of everything, basically.
The first cat image generator. Did I hear that right?
Yeah, the
that's
first.
So cool. True pioneer. No, that's really cool. I think on your website, actually, you have some...
Yeah, it's the Meow generator.
Yeah, that is so fun. Really cool.
And no, but that's like more, generative, my type of fundamental research, but I've also worked on more applied stuff. For example, I was leading the self-driving car project, which became a robotics project at Samsung. And I've also done a lot of work on molecule generation.
Very cool. How do you get to choose? Is it fairly autonomous where you pick something that's a topic you're inspired by?
They have many problems basically that they want to solve. That's a part I like because I really don't like a lot of companies. If you check the job is like you have to work on only one thing, LLM, one model or this. But it's like everything is a fad. Everything's gonna change over time. It's a bit crazy to me to be stuck in a box like this. So at Samsung, we get so many different problems and different projects. So you get to dabble in, you can dabble in a bit of everything if you want to.
That sounds amazing. I guess, question, you've with TRM, you definitely entered the world of ARC AGI. How did you first learn about ARC?
The first paper, right, about socially. So I thought this was super interesting, especially since it was so hard and people were not able to make progress on it. And that's the part that makes benchmark more interesting. It's very difficult. And I've been wanting to work on it for a while. I had been sidetracked with a few projects, but this was the time where I had the opportunity to work on it.
Had you ever tried any other, previous approaches or solutions before?
No, previously I looked into it, but I did not have the time to do it. It was just in the back of my mind as one interesting direction to.
I'm really glad you got to jump in and play because it was amazing what you did. So without further ado, let's jump into the paper. The paper talks mostly about TRM, which is Tiny Recursive Model, right? What is the story here? Like, how did this project come about?
The story is pretty funny too, because it started actually with my wife. So she noticed that my citation curve was going down, and she said it's
Your citation,
unacceptable.
like
My
paper citations.
Google Scholar, so this year it was going down, and said we cannot allow this. Yeah, so it came the project hashtag save the curve.
Save the curve. Oh wow, this is fun. Wow, that is some family support right there.
Yeah, but then it came with pressure, right? You have 1 month to do one paper.
Oh my goodness.
So yeah,
1 month. Wow.
Thankful, yeah. And then I was barely starting to look into recursion and HRM and all this. But the project really went fast. Like I really found and understood theory and iterated very quickly. When things are flow so well. So that's what happened for this project. Well, and it's always a good thing when this happens, when things always flow like this. So anyways, it went very well, but I didn't make the 1 month just because of complete. Just because I had the whole paper, everything. It's just the ARC experiment required 4 GPU for a few days. And I actually had it queued for 2 weeks on the cluster, the Compute Canada. It's like a Canadian cluster.
Mm-hmm.
And they didn't give me the GPUs. It was queued.
No.
I got a colleague of mine, Damien, who had more priority. So with him, I was able to have the job start finally.
It's definitely no fault of your own that you didn't finish the 1 month mark. But hey, it's a self-imposed deadline. So, and the result of everything, the sort of impact that time had is pretty amazing. You mentioned HRM, was that sort of part of the initial inspiration for TRM? I know it's mentioned a lot in the paper.
Yes, because HRM I thought was super interesting, but the reasoning, the explanation for the decision choice did not. I could not really believe them as much. They were all biology and stuff, and there was no ablation, no way for me to really disentangle things. But it was so interesting, so I really wanted to dive into it and really understand it at the fundamental level, and then figure it out and improve it, and that's what I did.
Do some science, kind of find out what's going on under the hood. Yeah, we had a similar reaction on the team at ArcPrize and sort of dug in on some ablation studies. Constantine on the India team chipped in there.
Yeah, Constantine did a great analysis. It was super great.
Yeah, I mean, you started digging in and then it sounds like you made quick progress. What was the first sort of insight you had where it was like, okay, we're going to actually improve the results on top of HRM?
Well, at first, I was trying stuff like fixed point. A lot of people have talked to me about that too, the fixed point TRM and that sort of thing. But in the end, I just ditched all of that. It's not really needed for the approach to make sense of it. But I just iterated on it incrementally and figure out like, the biggest thing I really wanted to understand is what is this ZH, ZL, like what is this thing, like why is it hierarchical and so on. And that's the biggest thing when I realized, it's just one is the answer, one is the hidden states. That's all it is. And that's a lot of the magic is from that, storing separately the answer so that you don't have to store it in the hidden state.
Yeah.
That's really a big part of...
Yeah, you got it. How can we describe to folks? Number one, they should go check out the paper. They should play with the code because it's actually like very usable. And I happen to know from speaking with other winners of ARC Prize this year, they noticed your model and they had attempted to kind of use it within their existing solutions. I don't think anyone succeeded at sort of integrating it in time, just because it was coming toward the end of the year's competition. But everyone paid attention, and they were pretty excited because it's so efficient. People were very interested in TRM. Can you put your finger on what sort of sparked so much interest?
I think it's the fact that it's a really small model, very, very small, and the fact that not overfit on such tiny data. Because that's the crazy part, even to me. Because the maze, for example, solving maze, you have 1,000 training maze. That's it. In fact, I thought I had data augmentation, but I had set the parameter to false. So I have no data augmentation whatsoever. It's just 1,000 maze. And yet you can get 85% test accuracy on maze you haven't seen before. Normally, models would just memorize. There's no way that they can generalize with such a few data point. So it's really the fact that it's recursive and it's so small allows it to think longer, but without overfitting. It's funny because I spoke to my PhD advisor yesterday, Yanis, and he mentioned one thing. It's like a looping back in time, because in the stats time, we were always regularizing to prevent overfitting. But then the neural network came out and saying, no, stack more layer, just bigger and better. It's always better. And now people are surprised again that in the end, no, we can actually regularize them, constrain them to be actually better at generalization. So it's like a whole circle going back.
Yeah. Do you actually have any intuition on why the sort of strong regularization helps TRM work?
It's hard to say for sure, but it's really preventing overfitting. And the fact is that it's able to reason over many, many improvements. It's just learning to improve. So it's very different from diffusion. People always tell me, oh, it's similar to diffusion. It's not similar. Well, it's similar-ish. But diffusion, you just noise and you denoise. Every time you noise and denoise, it's not going to be better. It's just going to be different. But it's really learning to improve its answer. But the fact that it's so small allows it to not overfit. But it's a fine balance. It's still hard to wrap our head around why this design space specifically is so powerful. But
yeah. By the way, what was it like discovering this? Like, I mean, it does seem like you came across some sort of unknown thing that the model could perform so well, being so small. What was it like emotionally like? And by the way, you were kind of had this bet or, challenge with your wife. Like, did you jump out and go, I did it, I came up with something really cool? Like, what was that like?
Well, at first I was confused. Why smaller? Why better? But then I got excited. But there was no big. It's more like at the end, after all, near the end of this work, I was like, okay, I might have something really interesting. Maybe I can top off my biggest paper, which was relativistic GAN. Because that made a big buzz at the time. And I always wanted to try, will I ever be able to top off relativistic GAN or not? And I'm like, this could be, this is very interesting, very, very different. And, but I wasn't sure for sure. But when it flows so well, when things go so fast, and it's the same thing that happened for relativistic GAN. The idea, it just worked, things work, everything was flowing, and it wrote itself also in a month-ish. So you have something good when things move along. But it takes 1,000 failure, to get this one that really works so well.
I have to tell you, I have a background in music, and so I'm a musician, and it sounds a lot like music. I mean, when you're composing music and it feels like it's just kind of flowing through you, it's almost like they're not your ideas, but you're kind of discovering them. I mean, you are creating the ideas. And also the thing about failure, like you gotta do something 1,000 times to have one be halfway decent or maybe even great, you know?
Well, it's not weird. It's not that different to me. Science and art is not that different. Like, because my wife also is an artist, so she does music, video, 3D stuff. So much different things, and it's the same kind of framework. Like it has to flow, it has to go fast. If you overthink things, if you spend too much time on one song or one paper or something. There's some also like inner, like indefinable like quality that happens from something that's actually you don't overthink it too much.
Yeah.
Like I see in academia, they really want to overthink things, overwrite it to be perfect, and I feel like that destroy a bit. Some of the simplicity and the ease and the beauty of it. I don't know. There's something good that comes out from just quick thinking and not overthinking it.
It's like flow state, you know, it's like a creative moment versus sort of an analytical, and it gets into this system one, system two type thinking that we obsess over in the sort of neurosymbolic land and deep learning and symbolic AI, you know? It's a rich playground to play in. So I hope people are inspired by your, the way this came together for you, and pay attention to like when those moments happen and probably run with it if you find that happening. Just top level before we dive into some more technical questions. How does it work? Like, you know, in a nutshell, like what does TRM do?
The idea is to keep track of your answer and improve it over time. That's the main novelty. And the other part is to think recursively, right, with a small model. But it's really about improving. So you can make mistakes, and the model learns to fix them and fix them until everything is perfect. So it's like learning to improve its answer, and that's the key part. Which with LLM, for example, it's auto-regressive, so every token is like permanent. You cannot remove them. We can make errors. I mean, everyone makes error. Like Evan Yanneken in his old presentation, he always mentioned the problem with auto-regression is eventually you get a wrong token and the whole thing is invalidated. But now people just do a ton of parallel thinking, so hopefully, and then the most common one and stuff like that to get something more reliable. But still, the fact is that it's very easy for them to make a mistake. So if you learn to just improve what you're doing, it's a better way from the start.
That's TRM in general. Let's dive in with some specifics. People are probably wondering things about just how this works, unraveling the riddle of TRM, if you will. How about training data? So what impact does training data have on TRM? And why did you include concept arc, for instance? And why not use more other training data to improve your score on ArcAGI?
So I've included concept art because it's a trustworthy data set. The problem is I've seen a few other data sets for ArcAGI that were made by LLMs. I didn't really quite, I don't know, I'm not trusting those. So I didn't want to include those. And I know I probably missed some other data set, but in the end, that was what I had. I just figure more data is better. Of course, you could add more as long as your data is high quality. You just want to make sure it's not like LLM incorrect question answer, because there's so much data that's incorrect, synthetic data out there that's riddled with errors or weird stuff. And but yeah, more data and more compute is better always. So
more training data would have had an impact, you think, on the performance?
I think so. But François Chalet disagrees. Not sure, but I didn't get to test it. To test like different level of data or just but it's to be seen. But to me, like the more data, the better it's gonna generalize.
Yeah, I mean, so the other side of that was compute. So you mentioned earlier about just getting access to the infrastructure to run it. Sounds like you probably called in some favors to make it happen as quickly as you needed to. Are you curious? What would happen if you had additional compute?
Yes, it gets better. That's what happened because Trellis Research posted this in last week, I think, that they trained it for twice as long and they added the extra data set. I forget which one, but I think it's mostly just training longer. That got them to 15%. It was on the public ARC-AGI 2. So the fact is, you can really. Even at I remember when I did the replication, I asked them, "Can you run it longer just to see?" But no, it's a replication, so no, because I was like, it tells it's run up. Like I don't think it's finished improving, right? So
Yeah, it's really cool. It really is magic that it performs so well. In some other testing of TRM, the inner depth appears not to be an incredibly relevant aspect as long as there's sufficient effective depth. What
no.
might explain that? What do we need to get right in terms of depth to see models train but not overfit?
It's not clear right now. You needed from the ablation. I saw that you needed some level of depth, but more was not helpful. But I did not get to try that on other example like ArcAGI because of course I didn't have the computer. So I really limited my depth based on the computer, the maximum I could reach
Yep.
for ArcAGI. Yeah.
That makes sense. There's definitely more left to be discovered there, I think. I guess, one aspect of this, you spoke about training data. What about the sort of, pre-training, fine-tuning strategies? Do you have any ideas there or saw anything that had a big impact on results?
So I like I said, I was very limited in compute. So it was one run and it was this run,
Okay.
right? I did not do ablation.
But we have questions, Alexia. We want to know.
No, but Trellis Research found a way to do pre-training and fine-tuning on TRM. So they have a short paper on this actually, so that if it interested people. But in general, it's just the idea of like there's other way you could pre-train fine-tune, like because right now it's a bit weird with the one embedding per data point. Like maybe you'd want some kind of in-context learning so that you don't need to retrain at inference or stuff like that. But it has to be determined. In the end, there's a lot of detail just for ArcAGI, but if we switch to ArcAGI 3, a lot of it becomes not super. Like if you go to ArcAGI 3, for example, we might not need all these tricks of specific for ArcAGI that were used. Because the maze and Sudoku were very simple. It's just you get the maze, you get the Sudoku, you solve it. I think for ArcAGI 3, it would be the same thing. You get your current level and you solve it. You don't need to have anything special to make it work.
Yeah.
It's because of ArcAGI 2 has this multiple examples that can cause some issue. It makes the context length very big, and you need some strategy to handle this.
That's really cool. You're checking out ArcAGI 3. Just for folks that don't know, you can actually go to 3three.arcprize.org. You can actually play some of these games. So the benchmark is kind of adding a temporal dimension and going beyond just the 2D puzzles to have interaction and sort of, agentic goals involved. Do you have a sort of an eye toward future solutions there, Alexia? Is that something you're curious about?
Yes, for sure. It would be cool to apply it in the future.
I guess, ArcAGI 2 still has a lot left to be discovered. So I'm curious to see, for instance, where competitors in ArcPrize will make use of TRM, especially because of the constrained compute available for running on Kaggle. It's very attractive for folks. It's still just really impressive what you were able to do with such limited constraints. Has anyone from the ArcPrize community reached out to you in terms of, using TRM for, integrating it with other ArcAGI solutions? Have you heard anything there?
No. I heard a lot of people wanted the help to make it work on Kaggle to get the prize.
Exactly.
To sell the prize, but I didn't have the time to do this. But no, that's mostly it. And I mean, a ton of people have all this kind of interest, TRM for this, TRM for that. Can you try TRM for that? None, never else.
Sounds like you're over it. I mean, let's talk about that. So the reaction just, internally at Samsung, how did it go? Externally, this got a lot of attention. I mean, there were articles written about it. Tell me a bit about the experience of sharing this idea with the world.
It's been amazing, like the reaction from the community. Like I was not expecting it to be that big. Like I knew it was very interesting, but not at that level. Like it was really, really next level. And the thing is, I haven't got message from the VPs in Korea who I did not contact. They just heard about it from Korean article, actually. They were sharing it around. So it was so cool. My colleagues at Cell have been extremely happy also because there was some uncertainty about the lab for a while. And because Samsung was struggling for some time. But with this, things become certain, safe. So my coworkers now are much less stressed.
Oh,
So everything is going well.
it seems like a great collaborative thing where it benefits the larger company. And thank you on behalf of the community for open sourcing these ideas.
I always open source the stuff. I mean, even if you do some research, I do some research on let's say closed source data set, I'm always gonna try to have some of these ideas applied to some open source data and release it.
Yeah. And what about the rest of the larger, academic or research community, outside of Samsung? What were the reactions like?
Also, great, a bit overwhelming. They want to present at this place, this other place, this other place, this other place. So I kind of try to limit the presentation. I did the presentation at Milo, a big event. It was filled. It was crazy.
I saw this. Is it the one that's on YouTube?
Yeah, that's the one.
I will link to it in the show notes so people can see that. I think that's a great deep dive too. And you had, slides prepared and everything. So if people want to live more in the world of TRM, that is a great place to go. Congratulations again. Like it's just so impressive, the work that you did. Definitely happy to honor you with a paper prize, with ARC prize. With this much interest on it, there's probably a lot of incentive to keep pulling the threads and keep exploring. But it sounds like you've got a lot of other ideas that you want to explore as well. What are you thinking about doing next? Do you think you'll spend more time with TRM?
Yeah, this is more paywall information, I would say.
Oh, right. Okay.
But yes, of course, I'm working on improving TRM and so many different applications for sure.
By the way, I guess this is probably too soon to tell, but remember your paper was a relativistic discriminator you mentioned? Is TRM poised to outpace in citations this previous paper?
For sure.
Oh my goodness. Congratulations on that. I'd say you won this challenge for sure that your wife set for you. I think in every way possible, you crushed it.
But still didn't make the 1 month because of confusion.
I think that's a technicality.
Right.
It's funny because on the Kaggle side, there's no room for, it's just your submission ran in time or it didn't. And it's binary, but
Yeah.
I guess, ArcAGI is really challenging. You knew about it before, you tackled it and used it as a benchmark to measure TRM. What do you think is special about the benchmark? What does it tell us about performance on models and just maybe even intelligence in general? Any thoughts there?
I think it's more challenging in the sense of a logic puzzle, a bit like the old IQ tests that were very popular back then. And this is the kind of thing that is very easy for human but difficult for AI, which make it very interesting, I think. Because there's a lot of benchmarks that are so easy to max tune. You just crank up the power and you solve them. But this requires some reasoning, some intelligence, right? Instead of just memorizing solution. Because one problem to the next is completely different. So you really need something that is able to think in more and deeper way, which allows us to discover new better solution to problem, which make it very interesting.
Do you have any thoughts about your work here, TRM, and your paper shows a sort of aspect where hyper minimalism, not maximalist scaling, there's alpha left to be discovered there. Do you have any sort of perspective on just, is the future small models, or are we going to kind of continue to just ever more increase the sort of scale of LLMs? Where do you see the future going?
Well, but both are good, but the problem with LLM is it's already a whole technology, I feel, and we're just trying to exploit it to the maximum. At some point, I thought the goal was to get real intelligent, and if that's the goal, that's not the solution. We have to still keep building new solutions, new techniques. It's not finished. The job is not done. And a lot of people are claiming it's just about scaling, and they're selling so that's real. You should spend millions on just scaling at some point. No, you have to invent new stuff. You need more fundamental research.
Wow, couldn't agree with you more. I mean, that is sort of our exact, advice to people in the ARC world. And, the super constrained environment of the Kaggle competition encourages that as well. Have you yourself looked into, non-LLM specific solutions toward advanced intelligence? So for instance, symbolic AI or program synthesis or anything like that?
I know symbolic AI is very interesting, but it's promising, but I have not looked into it much. And I know François Chollet is working on program synthesis, which is very interesting. It's just about figuring out the way to express things as program. I think this is a very interesting path to our intelligence. But I can say that this is the way, we don't know yet. But TRM was a way I explored to go against the grain of LLMs.
That's really interesting. I'm curious to see, what you'll pull in for future work. Your background has also a bit, some of your other papers, elements of psychology, human psychology, which is a big factor in the ARC world. People love, sort of cognitive science meets machine learning, brains and machines, this kind of a thing. Has your background in this psychology impacted your work at all with AI?
For sure, there's an influence because it's child behavior, child development, how the child develop, and the impact of the mother's mood, depression, and the father less so because the father is generally more absent. Like it's sad to say, but the mother is like the one thing that's consistent in a child life generally.
It's the primary care provider, right? It's the
And like seeing how the child develop different types of behavior and temperament just based on its environment. It's not, and I said the mother it was a big part, but we also check the genes, and basically certain children are more sensitive. So if you're a sensitive person, I am more of a sensitive person, then like how well you will do in life is really influenced by your environment. So if you have a good environment, you'll do better than most people. But if you have a bad environment, then you'll do worse than others. So, but if you're a resilient person, then maybe you're less influenced by whether your environment is good or bad. And I think these kind of ideas are interesting also for thinking about how to build a real AI, not just like next token prediction.
Makes me think of training data, but also, as we grow with, this temporal aspect of agentic AI, environment does become sort of a real thing that we consider. ArcAGI 3, as you mentioned, is working with that as well. So I'm curious too to see kind of what that will be. And the reinforcement learning is just taking off, and it seems like the next frontier of AI, since we've exhausted all the existing, human text and other kinds of training data, right?
Well, yeah, from the internet.
Yeah, exactly.
But but for internet is not everything.
Fair point. That is true. Do you think that if
do you teach your child with Reddit and
No.
advanced mathematics? No.
That would be a terrible idea. Although I do think kids these days probably, learn an awful lot through social
yes,
media. It's not a good thing, but it is true. That is really interesting. I'm trying to think of the other angles there, but a lot of it is the people are excited about just how the human brain works, like, and looking at, what we're learning in AI and then sort of comparing that to what could be happening, with neurons in the brain and that kind of a thing. People have been really inspired by your work this year. Do you have any advice for people? ArcAGI is difficult. Like, it's a very data constrained regime. If you're competing in ArcPrize, there's the sort of constraint of compute and no API access, no internet access. Do you have any advice for people? You're sort of the champion of less is more, right? Any advice for people diving into this very challenging world?
It's hard to give clear advice, but really, it's just general advice. Basically, read paper, start from a code base that already exists, so that it's easier to iterate and try to re-understand papers and code and explore things in this way, and eventually you can see if some things comes out. Just do a lot of exploration, basically.
That sounds like a pretty grounded approach. Make use of previous ideas and, maybe next time, get more compute and be able to run more iterations, I guess, would be advice, that I would learn
it's not an advice. Okay, people don't have that much compute. It's difficult to get. Right?
It is so difficult. A bunch of these winners that I've been speaking with had a little bit of sponsorship by, like NVIDIA in one case, because the winning team, top scorer, is a team of Kaggle grandmasters, like on an internal team in NVIDIA. So they had a little bit of help there. And then another one with Lambda AI, like, provided some compute resources. So Alexia, thank you again so much for open sourcing your really brilliant ideas that just, again, captivated, I think, the industry. Just very impressive work. Could not deserve more this credit of winning ArcPrize 2025 paper award. And thank you for spending some time with us today. We really appreciate it.
Thanks so much just for choosing me and helping me replicate also the paper. And I'm really very, very thankful. And I would like to obviously give my thanks to my family and my advisor, research advisor, who have been integral in making me the researcher I am today. And especially my mom, who helped me move in the social ladder, because she really didn't want me to end up like in her position, like a job that you cannot move from and you have no prospects. So she really pushed me toward books and academia in general. And then obviously also my wife. I mean, without her, TRM wouldn't exist. And she's really the smartest person I have ever known. Like, you won't find anyone smarter than her. And she challenged me so much every day and makes me grow. It's crazy. Marry a very smart woman. That's the way. It's the life.
The secret to life.
Yeah. And I would like to extend also my thanks to all the folks in Korea at the AIC and all my colleagues in Montreal at SAIT, except Simon, who have been all amazing to work with and for which I am extremely grateful for.
That is so wonderful, Alexia. Just, huge shout out to all those people supporting you and, supporting each other. What an amazing community. Grateful that they have supported you and enabled you to, get to this place in your career. So huge shout out to all of them. But thank you again. Thank you so much for speaking with us today.